In this video, we're looking at finding angle measures with angles formed by parallel and perpendicular lines. So as is to first recall some definitions that we should remember. Corresponding angles are two angles with corresponding positions. So an example here, if we look at angles 1 and 2, they're both above and to the right of this transversal. Parallel lines are two lines that do not intersect but are coplanar. Coplanar means they're on the same plane, but they do not intersect. Supplementary angles are two angles whose sum is 180. These two angles add up to 180 degrees. And vertical angles are two angles whose sides form two pairs of opposite rays. So an example of vertical angles would be these two here. We also should remember that vertical angles are congruent, always congruent. Okay, so we're going to look at some theorems and postulates that involve angles formed by parallel and perpendicular lines. Specifically, these first four are going to be looking at angles formed by a transversal. So you'll notice as we start to look at each of these that they all start out by saying if two parallel lines are cut by a transversal. So that's the stipulation we're starting out with. Two parallel lines cut by a transversal. So this picture we're going to look at to explain all four of these theorems. The corresponding angles theorem says if two lines are cut by a transversal, then the pairs of corresponding angles are congruent. So we mentioned earlier angle 1 and angle 5 are examples of corresponding angles. They're both above and to the left. Or angles 2 and 6 are also corresponding. So because these are parallel lines and because angles 2 and 6 are corresponding, angle 2 must be congruent to angle 6. Or similarly, angle 3 and angle 7 are congruent, angle 4 and angle 8 are congruent. The alternate interior angles theorem tells us if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So notice here alternate interior, so they're on opposite sides of the transversal, but both inside are parallel lines. An example is angles 3 and 6 are alternate interior angles because these are two parallel lines cut by transversal. Angle 3 must be congruent to angle 6. And similarly, angle 4 is congruent to angle 5 because those are alternate interior angles. The next one is the alternate exterior angle theorem that says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So alternate exterior angles are outside our parallel lines but on the opposite side of each other. So 1 and 8 are congruent, 2 and 7 must be congruent. The last one I put 2 stars next to, and I would encourage you to underline, highlight, star, something to remind yourself that this one is different because all of these look very similar and we get to reading this one and it says if two parallel lines are cut by a transversal, and it's really easy just to say then the pairs of consecutive interior angles are congruent, and that is not correct. If we look, we notice that angle 3 here is an acute angle and angle 5 here is an obtuse angle. So if we just think about it, it doesn't make sense to say that consecutive interior angles are congruent to each other because an obtuse angle cannot be congruent with an acute angle. But if we think about things we know, they end up being supplementary, or they add to 180. If we think about this for just a minute, we know that 1 and 3 form a linear pair, so these two have to add up to 180. And we just said that 1 and 5 have to be the same angle because of the corresponding angles theorem. Sorry, they have to be the same measure. So if 1 and 5 are the same, and 1 and 3 add up to 180, wouldn't it make sense we could substitute in angle 5 and say 3 and 5 add up to 180? That's how we got the consecutive interior angles theorem. And in fact, we could prove each of these. If we think about angles that we know are congruent. For example, we know that angles 2 and 3 are vertical angles, so they're congruent to each other when we have parallel lines. Actually, sorry, vertical angles are regardless. 3 and 6 are alternate interior angles, so they're congruent when we have parallel lines. That means 2 and 6 are congruent. Even if we didn't know because they were corresponding, we could show by substitution that they're congruent because they're all congruent to each other. Or similarly, we could say that 6 and 7 are vertical angles, so 2 and 7 are congruent, showing the alternate exterior angles theorem. Okay, so we're going to look at some examples of when we would use these. This asks us to find the measure of angle 1 and angle 2 and tell which theorem we use in each case. So if we look at angle 1, this angle is alternate interior angle with the angle shown here. So the measure of angle 1 is 110 degrees based on the alternate interior angles theorem. Now if we look at angle 2, these two angles are corresponding angles. So we can say the corresponding angles theorem, theorem tells us that the measure of angle 2 is also 110 degrees, which we could also use that we know that angles 1 and 2 are vertical angles, so it makes sense that they're congruent. But we're going to practice these theorems we're just learning today. All right, if we look, angle 1 is corresponding with the 63-degree angle. So the measure of angle 1 must be 63 degrees, and we know that based on the corresponding angles theorem. If we look, angles 2 and this angle are consecutive interior angles. That means the measure of angle 2 plus 63 degrees equals 180. We subtract 63 degrees. We end up with the measure of angle 2 is 117 degrees, and that would be because of the consecutive interior angles theorem. In the next example, these two angles are alternate exterior angles. I should have mentioned this up above, but these theorems only apply if we have parallel lines. So notice up here we have parallel lines, here we have parallel lines, here we have parallel lines, and in our last example we also have parallel lines. So because these are all parallel lines, these theorems apply. The alternate exterior angles theorem tells us that alternate exterior angles are always congruent. So we can say, we know that means their measures are the same. So we can say x plus 12 has to equal 110. That means x must be 108 degrees, or just 108. We're going to plug it back in to show that. Oh, wait a second. 110 minus 12 would be, 98. X must be 98. 98 plus 12 is 110. Yeah. And lastly, if we look, these two angles are vertical angles, so we know they're the same. These two angles are consecutive interior angles. So because they're the same, we can say 2x minus 3, we know consecutive interior angles add up to 180, so that's what we're going to do. So we look to solve this, we're going to add these up to 180. So we can say 2x plus, if we simplify this side, negative 3 and positive 153 would be 150. We subtract 150 from both sides, we're left with 2x equals 30. Divide by 2 and x equals 15. So we could plug that back in. 2 times 15 minus 3 would be 27. 27 plus 153 adds up to 180. So we know we got the correct answer.